got a hat on right there, dude.
These things have been tossed.
Huh?
No, they're about
Actually. Anyone else not have a hat?
Oh, by the way, we like 6 people.
Austin, does anyone else not have a hat?
Oh, I didn't know.
Roasted.
Okay. Guys, I need you to log onto these calculators. We got math to learn out of this. I know that's all scary. Sorry, we don't have math to learn. What do we have to learn? Statistics. Woo! Way better than math.
Sciences. Yep.
What?
Mathematical sciences. As you have said.
Yep. It's a mathematical science.
Why am I missing one?
You weren't.
Where did it go?
Wait, did I send the wrong one out?
Yeah, you did.
Yeah,
That was
it said
one-
tennis.
Yeah, not that
Oh,
one.
yeah,
You
that's
sent me, you sent me the
I'm
correct
holding
one.
it right.
Alright,
I don't know
well,
where I got a calculator from.
It's probably gonna send tennis first.
It shouldn't. I only have horsepower pulled up.
oh,
I got it.
Do you have horsepower now?
Yes.
Okay.
I already had horsepower.
I'm sorry. It won't change anything. Some people had tennis. I don't know why, but they did.
That's what you sent out first.
Oh, I
That'd
don't
beat
remember
everybody.
putting out those tennis.
Yeah,
Oh, yeah, I won.
Okay. So, quick question, and so there's a couple of important principles that we need to learn out of this. First off, what are my explanatory and or response variables? So mass and time are the what? Explanatory? What is power then?
respond.
Okay, so explanatory means that these are going to do what for the power?
Effective.
They're going to what?
Like, have an effect on it.
Yes, but not just that. Think about the idea of a linear
There's
regression.
going to be a correlation between the two.
There is going to be a correlation, meaning that the mass or the time is going to do what for the power? There's another P word I'm looking for.
Predict.
Say it again.
Predict.
Predict, right? The whole point is that we want to make predictions. And so when I talk about it that way, which one do you think is going to predict the power the best? Is it going to be the mass or is it going to be the time?
That'd be mass.
Math.
Mass? Why are we thinking mass?
It changes more.
Okay.
People have a harder time like moving
Okay.
faster.
Have you ever gone
Although actually, I feel like
Never
kind
got
of,
a question.
Well, hold on to that.
Body
Don't
weight
make me forget.
correlation.
I mean,
mass could be
it would be like that drastic though. Like everybody in here like relatively.
Well, so here's the question though. How are we going to figure it out?
Linear.
Five areas.
So there's two things that we want to consider, right? And I'm going to introduce a third one today, right? So what are the things we know in order to figure out which one explains or predicts the power the best? What can we do?
Run a test.
Okay, maybe run a test. Not going to go to that point. We're not doing much with inference procedures and bivariate data, but good thinking. Yeah, running a test could work.
Look at a line.
We could look at a line, we're closer.
You compare the line between time and power and between mass and time.
I don't know about a line. Someone said graphing it, but what are we graphing here?
Pairs.
We're graphing pairs of data. What's that called?
Match pairs.
No, because it's not the...
Squares line or something.
Okay, there's something with a least squares line, but come on, there's got to be something before that. Starts with an S.
Slope similar.
And we got pairs of data. No. An SC.
Sclerosis.
Scatterplots.
There we go. It's got to be a scatter plot. How are we going to know what the data looks like without a scatter plot? How are you going to have a least squares regression line without a scatter plot?
You're not.
You're not, right? So how are we going to figure out which one best predicts? We got to look at the what?
Scatter plot.
Thank you. Okay. So create a scatter plot of our data. There are now, actually pause. But before we even do that, there is another thing that you have learned that calculates the core, no, that's not what I'm saying, that calculates the strength of the relationship. What have we learned about that calculates the strength of the relationship? Not power, not what? The least squares regression line is the best regression line, but I'm talking about what measures. Okay, let's get our notes out. R, thank you. Guys, we got to be studying our notes some. What does Okay, so we gotta look at R as well, but do this for me, create a scatter plot, and then let's figure out what R is. I think you were you? Okay, so I'll show you in a second, but also, when you miss a day of school. Yes.
Y-axis.
Would you make 2 of them?
Okay, so remember, well, let's think about it this way, and make our job easy. What do we think was gonna be the better explanatory variable?
Mass.
So let's look at mass. Which axis is explanatory gonna go on?
X.
The x, right? And then what's gonna go on the y, the response? And we gotta create a new page. Power will go on the y-axis, right? So add data and statistics, number 5 or 6, I think.
We said math on the X.
Mass on the x, explanatory, response needs to be
Power.
powered on the y. So, data and statistics, mass, and power. So, first things first, because this is on the mock exam, this is on almost every AP exam, and we got to review this, and I need you to look at this. How would you describe this relationship?
Positive, linear.
Strong, positive, linear.
So maybe maybe a moderately strong. What else?
Positive.
Positive.
Linear.
Linear. Guys, do you know how many of you who tried number 5 forgot the word linear? What are the things that we have to talk about with a relationship with this? We got to talk about the strength, the direction, the shape, right? Strength, direction, shape. Moderately strong, positive, linear, what? Relationship. Because notice, we don't have a line yet. The linear is describing the type of relationship. There's one other thing that many of us forgot to talk about on the mock exam. There's one other thing.
Correlation?
We don't know the correlation unless we've calculated it. I might say this point could be one of these.
Oh, I know what it's called. I know you're talking about.
A potential outlier. So remember, there are the influential points, right? The high leverage and the potential outliers. Now, this is probably not an outlier, but notice if I take away these 2 points, what happens to that line? It becomes, is it still moderately strong?
No.
That's really strong.
No, I would say then it's a strong linear relationship, right? Okay, so those are potential outliers. They heavily affect the strength of the relationship, but that's what we got to talk about, right? Strength, direction, shape, and potential outliers, those influential observations. So, 2 potential outliers. Now,
What's the difference between an outlier and a leverage point? Really the same thing?
so so does anyone remember, because this is important, what's a high leverage point versus an outlier?
The high leverage point was the one that was like away from it. Like the first one could, possibly like it brings it in that direction.
I wouldn't say this one, maybe if it was like further
Yeah.
this direction, way over here.
Yeah.
High leverage means it is very far away,
Something like that.
Whereas
an actual,
the like median.
but not just away from the rest of the data, it's far away which direction?
Spread out.
Guys, horizontally.
There's a gap.
Oh, it's pretty.
Horizontal, right? If it's far away horizontal and it really controls the equation a lot, that's when it's called a high leverage point.
Gotcha.
Okay? Notice this is further away in which direction? Vertically from what would be our least squares regression line. And that doesn't heavily affect the equation line, but it does heavily affect the correlation coefficient, the R, right? And so if it's vertically far away, that's when it would be an outlier. They're both influential observations. And so you could say that there's two potential influential observations. You could say that there are 2 points that deviate from the general trend, things like that. Okay, now, let's look at the other one. Let's look at versus time.
Can I just make another one? Or you have to change it from here?
Well, what, did you know you can click on the y-axis variable? So if you click on the y-axis variable, you can change it. Look.
Well, I'm just
Oh, not the y. We want to change the
That's what I was
x.
asking.
So you just click on the mass, you change it to time. Oh, now, when we look at the time, do you think it's a stronger or weaker correlation? Weaker. It still might be moderate though, right? But how would we describe this one? Maybe a moderately strong, negative, linear relationship. Because of the amount of scatter, I don't think I would consider this an outlier. But remember, that's why we say potential outliers. It's a little bit of a deviation from the rest of the data. Okay, so we have that set of data. Now, I will point out on the back side, you need to make a scatter plot. Does it need to be super accurate here? No, but do a little bit of a scatter plot for number 1 for each of these, and then I need you to just work on numbers 2 and 3 and 4 and 5. We're going to talk about a couple more of these things, but work through those. We're going to come back together soon. So let's look at this. Remember, and you can use the mx plus b, but the traditional one in the calculator is a plus bx, right? Here's a, boom. Here's b, boom. A plus bx, right? That's it. You put your a where a is, you put your b where b is. You got your r down here. By the way, what's the name for r? Correlation coefficient, right? Sometimes if you ever take another stats class, you'll hear it called Pearson's correlation coefficient, but we just call it correlation coefficient for the AP exam. I think Peyton was asking about r squared. I'm going to teach you about that soon. It's called the coefficient of determination. It is important, but not as important as the correlation coefficient. So questions about the r in the equation there. Now, a word of caution. Do you know what several of you missed that is really important for that least squares regression line? Well, yes, we need that, but Austin, you're still missing it if I remember correctly.
The hat.
Okay. Not even just the hat. I had a lot of us that were missing this whole piece here.
Negative.
No. Everything to the left of my hand.
Oh, y.
Y hat equals. Guys, this is a regression equation. You gotta have the y hat equals. Okay? It is a prediction. So, now I will point out, notice I have this statement about a better version underneath it. What do you think I mean by that? There's a way better way to write this. What would it be?
Would you just solve it?
The predicted.
Well, pause. The word solve means find what makes the equation true. That we're not solving anything. I'm saying a better way to write that equation.
Sorry, simplify it.
What are you going to simplify?
I don't know, maybe the plus part.
But we're multiplying. Can you add before you multiply?
Could you multiply it?
No. Because it's a variable.
Would you write it out?
Maybe.
What it means?
I was just saying, does this y and this y mean the same thing?
Yes.
Does this x and this x mean the same thing?
Yes.
No.
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 They do not.
Because what is this y for both of these?
Horsepower.
Horsepower. What is this x though?
Mass.
What is this x?
Okay.
If we don't have it with our variables in the place of it, then it's harder to remember that. So how can I rewrite y hat? Horsepower. Horsepower what?
Predicted.
So hat. Oh, that was hideous. Horsepower hat, right? Predicted horsepower is equal to negative 0.0913 plus 0.0134 times what?
You just say kilograms.
You could do that, but that's units. What's the variable?
Oh, it's mass.
Times mass. Right? So I would use the variable, not the unit. Same thing here. The predicted horsepower is equal to 1.902 minus 0.5035 times, what's x?
Time.
Now, it's going to be way harder to make mistakes. Put your variables in there instead of just x and y.
Oh, my head hurts.
It will make your job way easier in the long run.
Looks more explanatory.
Exactly. X and y are just letters. Horsepower is predicted by the mass. Horsepower is predicted by the time. Okay? A quick note that I want to make, actually, do we all have that updated? The better version, we have our better version?
Yep.
Okay? I want to point this out. I saw someone who had this as their correlation coefficient earlier, and I knew immediately for that horsepower versus time that that could not be the right correlation. Does anyone know why? So why does it need to be negative though? Right, remember that negative versus positive tells me the what? The direction, right? Which is part of that slope. Notice right here how my slope was negative? So what does R need to be? Negative. We want to pay attention to that, right? So they need to have the same slope. So okay, let's look though, when it says find the correlation coefficient, write what it means. So I want to caution you, a lot of you interpreted it, great. But what does the correlation coefficient mean? This is the strength and direction of what kind of relationship? R only works for what?
Linear.
For a linear
Oh,
relationship.
is that what R squared is?
Nope.
Quadratics?
It is related, but I will explain that soon. So the R is the strength and direction of a linear relationship. And so we would interpret this now, but be careful of the difference between what it is and how we interpret it. How would I interpret this?
Moderate,
So a moderately strong,
Positive.
positive,
Linear correlation.
linear, not correlation,
Relationship.
relationship, right? That we're interpreting the correlation, right? It's a moderately strong moderately strong positive linear relationship. Strength, direction, form, or shape. What questions do you have?
Okay, so with the R squared, because
Don't worry about R squared yet.
I know, but
Okay.
my eyes are getting bad as deacons right now. And I couldn't tell where the other R is, so
I mean, this is
I
R.
just
and so this
square
is R.
rooted,
Delete my
Yeah.
brain.
and I got that that's okay.
So yes, just
But
make sure you pay attention to positive versus
Yeah,
negative.
I
'cause-
didn't.
Okay. Let's see. So how would I interpret this R?
A negative or a strong linear negative relationship.
Would we call this a strong?
Moderately strong.
Moderately strong,
Negative
negative,
linear relationship.
linear relationship. Okay? Now, I need you to hear me very clearly on this. Actually, this is just quick recap. What is the R for a strong linear relationship?
One.
So, well, that's perfect, but strong is anywhere between
0.8.
0.8 and
One.
1. Moderately strong is between
It's like
0.5 and 0.8. When we're focused and not doing a helicopter with a ruler.
All right.
Yeah. So, 0.5 to 0.8. Yes, Aaliyah.
Can I go to the bathroom?
Okay. Now, we have got to talk about the interpretation of slope and things like that. But before that, I want to do one thing because I want to show you one other important part. It's not on this sheet, but it is a critical piece for understanding which relationship or which prediction is better. So, pick your calculator back up. Have your time and your power.
Like on the chart or on the scatter plot?
On the scatter plot, because you should already have all of it there. But on the scatter plot, I want you to have time on your X, power on your Y. Now, what's the button that lets me do cool crap,
Menu.
Bryson? Menu, right? So I'm going to go to menu. Alright. We want to analyze this. Make sure you have a... I just want to point this out. You notice how residuals is not an option right now? It's all grayed out. You have to do a linear regression first. So do your linear regression. After that, I want you to go back to menu and analyze, okay? So I need you to create a linear regression, go back to analyze. So not the squares this time.
Does it matter which graph?
Plot?
I want you to do time and power right now so that we're all in the same boat.
What the heck?
So there is the show residual squares, but it says show what?
Residual plot.
I want you to create a residual plot.
Oh. Why did two?
I saw it on the test one time.
So this is a small version of what we were just looking at, right? This is called a what?
Residual plot.
No, this one.
Oh, that's
Scatter plot. This is called a,
residual plot.
How did you put the second one?
when you go to menu, analyze,
Oh, something else.
wasn't there a section for residual there?
Yes, sir.
And so there's an option for show residual plot.
Gotcha.
What in the world do you think we mean by a residual plot?
Plot of all the residuals.
So it's a plot of all the
Residual.
residuals. So what do you think this is right here?
How
Residual
far they are away
distance.
from the point, the line?
So how far that, but notice right here, this is a residual, right? So what is this telling me?
It's really
How
close to
far
the
a point
line.
is away from the line?
Not just how far,
The average.
no, not the average distance.
It's really close to the line.
Yeah,
Vertical distance.
you said just how far, but it's not just how far.
How close?
The vertical distance.
Yes, but come on, remember a point can either be, the residual can be positive or negative, meaning it's either above or below. Right, there we go. So it's not just how far, we got to recognize, would this point be above or below the line?
Above.
It'd be above, right?
Oh, that one.
Okay, so I want us to look really quickly, and I want a quick volunteer. Any guesses what point this is on the original graph? I've seen this show up on free
The one
response. Come
right
on,
after
Alyssa.
the point.
That one right there.
Okay.
Wait, want me to come up and show?
Yeah.
Oh,
That one right really long.
That one right there.
That one.
one of those.
I'm gonna just guess.
I'm just gonna point
This
this.
is on and off, right? I've seen this.
Okay, what do y'all think? You agree?
Yeah.
Why does this one make sense?
Because that's basically that graph
It
just
follows the
rotating
shape
down.
of
It's
the
just-
dot.
Okay, pause, and I need y'all to hear me on this, and this is what I need you to listen to. Say that one more time, Ashton.
That graph is that one just rotated down. So
So-
like imagine if you're basically rotating it so that that's like flush, I guess parallel with like the bottom of the board.
Okay, there's another word we could use for it, but this least squares regression line has been made what? Horizontal, right? It is rotated so it is horizontal, and so that we can more clearly see these points. Notice these two right here are simply these two right here. This one is simply this one, right? These three that were heavily grouped together are these three right here. So when we talk about that residual plot, okay, we can now see the graph in that scatter plot a little bit better. And I'm going to show you some of this in a second, but one of the things I want you to hear me clearly on is this. A good linear relationship shows scatter in the residual plot, which I know sounds wild. And you're like, Mr. Kinney, why does that matter? I'm going to show you in 1 second. So a good linear relationship shows scatter in the residual plot. Nope, not what I wanted.
Huh?
Nah, because there's no scatter that will balance out.
Okay?
At least that's what I think.
Beheaded.
Okay. So I want you to look at this. Anyone know what kind of function I am currently typing out?
X squared.
X squared. A quadratic. Is x squared a linear relationship?
No.
No, definitely not. But watch this. If I do menu and I go through my statistics, nope, that's not. Oh, that's fine. I'm going to make x value my x list. I'm going to make y value my y list. If you were to just look at that R, what would you say about the relationship between my x values and my y values? That's a very strong, positive, linear relationship. But hold up. We just said that this is what type of function? It's nonlinear. It's a what? Quadratic. So can we ever just look at R to know how good of a fit it is?
No.
Watch this now. So I'm going to go here to my variables. I'm going to graph my, no, that's not what I wanted. Come back. Okay. X value. Y value. And you can now see it. It still looks, it could be a little linear, but watch this. When I analyze and I do my regression and I analyze my residual plot, now all of a sudden we can very clearly tell. Is that scattered or is there a pattern?
Pattern.
So look again, when we say scattered, it just kind of means all over the place. But I can very clearly draw a curve through those points. If your residual plot shows a pattern, that's a bad linear relationship, or it's not a linear relationship at all. Hear me again on that. If your residual plot shows a pattern, shows a curve, it is a bad linear relationship. Or it may not be linear at all. So be careful about that, make a note about that. A good linear relationship shows what?
Scatter.
Shows scatter. Notice, is there any clear pattern to how these points are around here?
No.
No, right? That's what I mean by scatter. Okay? Alright. Sorry, I'm using this as a teaching thing. One thing, alright, so now, let's say I change this time to mass. Look at that scatter plot. Based on this, or look at this residual plot. Based on this residual plot, do we seem to have a linear relationship?
Yeah.
Yeah.
Very much so. I also want you to look at this residual plot, because this residual plot also can very clearly show me, not clearly, but it can give me a better insight into what kinds of points. Austin, head up.
Potential outliers.
Potential outliers and high leverage points. Looking at it this way, does that now look potentially like a high leverage point?
Yeah.
Notice how it's very close to the line, and horizontally it's pretty far away, right?
Yeah.
So our residual plots are good for us to assess form, and they are good for us to identify potential outliers and high leverage points. Now, I'm not as certain about these being potential outliers. Because that point's about the same distance as that point from the line, right? So, be aware the x-axis stays the same, right? So along the x-axis is my mass, and what's along the y-axis?
That's the
Power.
residual,
Or
like a value of the.
It was power here, but here it is the residual, the distance above or below the which one? The least squares regression line. Okay. I want you to just attempt to interpret the slope in the y-intercept for horsepower versus mass, and then we're going to come back together in just a minute, okay? So just the horsepower versus mass, and we're going to come back together in just a minute.
Number 4. I.
Sorry, yeah. Haley, what's my y-intercept
for the
for horsepower versus mass?
0.0134.
Okay? We all good with that? Aaliyah, you made it sound like you're not good with that.
Oh, I'm not good with the noise that that worker is making.
Oh, we all good? Is that y-intercept?
Yes.
Wait,
Hold
Which?
This is y-intercept.
Is it BX?
That's the,
That was close enough.
that's the slope.
Y-intercept.
So,
No, wait, no.
remember, we're used to mx plus b, but slope is multiplied by x. Remember, the idea of slope is an additive rate of change, and what shows repeated addition?
Multiplication.
Multiplication. That's why this multiplication is my slope, right? Multiplication is repeated addition. And in statistics, this is the traditional way to write it. So what is my y-intercept actually?
20.
Okay? Now, you're actually missing something critical for this y-intercept. The x's, remember, everything on a scatter plot has both an input and an output. And that's important because this 0 is what? Which variable?
So in that case.
Remember, the x comes first, right? Which is my what?
Mass.
Mass. What is this?
Horsepower.
Close.
Predicted horsepower.
Ah, that's right. Everything y is predicted. Remember, I wrote it this way, and I recommend to write it this way because as soon as you write that variable with it, it's easy money interpreting it, right? So Bryson, 0 what? 0 what? But what is it? I know, I can tell. Look at it, I wrote it above the number 0. Come on. Which one? Is it y-intercept or is it mass? There you go. So 0 what? What is your mass measured in? 0 kilograms. So, if a person weighs 0 kilograms, then what?
The predicted horsepower is negative 0.
Their predicted horsepower is, and really it shouldn't be weighs, it should be mass, but it's fine. Their predicted horsepower is what?
Negative 0.09134.
Notice guys, put your variable with your numbers. Soon as you put the variables with the numbers, the context makes sense. The mass, so if a person's mass is 0 kilograms, their predicted horsepower is negative 0.0913. Or they are predicted to have a negative 0.0913. And so what is my, actually before I move slope, what are your questions about that? Good with y-intercept? Deacon, you good? You seem out of it. I can tell. Get some sleep. Peyton, you good? Yes, no, maybe so? Okay, Alyssa, Haley, Logan. Okay, so slope then. First off, Lexi, what is my slope? Like, what is the value, I should say?
Is it 0.0134?
Okay, so remember, we already used this as our y-intercept, right? So my slope has to be
The B?
the b, which is?
0.
There we go. So remember, I also already said it, the slope is multiplied by the variable. Slope is an additive rate of change. We're repeatedly adding that slope over time, okay? So, the slope is 0.0134, but Peyton, in general, how do we calculate slope?
Don't you just do y over something?
Yeah, something like that. What is it? Change in,
Oh, changing y over changing x. Oh, change, yeah, sorry.
so change in y divided by change in x. But I feel like we're missing something there.
Isn't it changing y hat over changing x?
That's right, we're dealing with statistics and we're dealing with predictions. Is this line every single one of the actual y values? No, it is predicted y values. And I see the change in y hat. What is my change in x?
0.
Is it 0.013367?
That's my change in y hat.
Would it be 1?
1.
It's understood to be divided by 1.
Alright.
So unless it's already a fraction, it's understood to be divided by 1. Or y hat is what again, Bryson? What's the variable for y? What's the y variable? Thank you. Right? So what we're talking about is the change in horsepower divided by the change in mass. Put your variables in context. Now we just have to read the interpretation. So Tyler, I gotta ask, this is an important thing to think about. Should I start with a statement? I'm not saying you have to do this every time, but it is easier in my mind. Would it be easier to start with a statement about the response or the explanatory variable?
The explanatory.
I mean, personally, the explanatory is independent, isn't it?
Yes.
So I start there. You don't have to, but I would start with my explanatory. So one what? For every...
One person.
For every kilogram.
So for every extra or one more kilogram,
You gain.
the horsepower increases by?
The predicted horsepower.
There we go. Do not forget this is predicted, right? So for every one more kilogram, and I will say this, I would say the horsepower, you can say predicted horsepower, but I would say the horsepower is predicted to what? To increase by 0.0134.
No.
That's how we interpret. You gotta know how to interpret. Austin, you got all that written down so you can refer back to it later? Okay. So for every one more kilogram, and we could say of mass, the horsepower is predicted to increase by 0.013. If you do not have that word predicted, if you do not have your independent and dependent variables there, you will lose credit on the AP exam because that is statistically accurate. Great.
Look it up now.
Look, it is great. You now know, so don't make that mistake.
He said it was great, so.
Yeah, that sounds great.
Okay. So, like you're dead, but also you are tired. All right.
I mean, I had it down. So.
Yeah. It's true. It was exhausting. I guess I needed to not do the horsepower lab in the future because it wears us out so much. Okay. I'm gonna have to leave the next one alone just because of the sake of time. Which of the explanatory variables was best?
Mass.
Mass. Why?
The absolute value of the R, yeah, the correlation coefficient was larger for mass, which means that it has a stronger linear
And
relationship.
that's what I would say, right? Because the positive or negative doesn't matter a ton. We can just say that R indicates a stronger linear relationship. Positive, negative doesn't matter, which I understand that's why you're saying the absolute value, right? But the idea that R indicates a stronger linear relationship. And do they both have, and here's the thing, this is why we looked at this. Do they both have decent scatter in the residual plot?
Yeah.
So they're both linear, right? So it's not enough to just have a higher R. We also need to check that residual plot to make sure it has good scatter. Yeah. So it has good scatter. All right. So Deacon, hold on to your hold on to your progress check question because we're not going to be able to do the demonstrated understanding tomorrow. We'll do it on Thursday anyways. Don't let me forget.
Yep.
I know, I'm sorry.
I'm coming back
But-
from,
There's no sense in rushing it and doing it tomorrow, and I can't wait till Friday because we got to get to full-time review. All right.
I don't think Friday either, so
I'm sorry.
Sounds
Y'all are going to be here half of the next 10 days, so.
you're right.
Okay, so y'all are going to need to come in for something to finish this stuff up. All right, so again, how do we determine, so this is off the notes, right, from the traditional set of notes, and we got to do as much to get through all of this as possible tomorrow and demonstrate understanding on Thursday, test Friday or Monday. So, notes, please have those out. Not time to leave yet, only a few more minutes.
Let's go.
I know it's 11:04.
It is not 11:04, it's 11 o'clock. How can we determine the best regression line for a set of data?
You guys want to
R is close.
Okay, but not just put it into the calculator. It's not just R. What are we doing? Think about back to the squared up task. We tried to do something.
We're trying to reduce the sum of the squares.
All right, so we want to minimize the what? Minimize the sum of squares. So minimize sum of, and by the way, where are those squares coming from?
Residual.
Right, so sum of residual squares. And yes, we're gonna get from the calculator, but what's the name of this, least squares regression? Remember, it's all called regressions in the calculator? So least squares regression line. Bryson, do you remember the acronym that we use?
There's what, LS?
LSRL.
RL.
If you ever see that, least squares regression line. Minimize those sum of squares, least squares regression line, but it's just in calculator. Okay. Aaliyah, you okay? Smile. That's the opposite of a smile.
Well, that's what I was
So-
trying to
How do you use a calculator to find the equation of the least squares regression line?
Regressions.
So we can analyze in what page? In data and statistics, right? So analyze a scatter plot in data and statistics. Is that the only way?
The only way that matters.
Well, you can
No.
take the sum
Oh, I have two
of
squared
every
up.
like residual.
Or is it just?
You take every residual.
You're overcomplicating it.
Okay.
Calculator. How can you use the calculator? We got a data and statistics page, but we can also see it in the
Spreadsheets.
graph is the data and statistics.
Well, let's listen.
Listen spreadsheets, right? So remember how we went to statistics? And from statistics we said, I think is it analyze data? No, what is it called?
No, it's calculated.
Stat calculations.
Yeah, like,
So statistics, stat calculations,
And then it's the regression.
and we want the linear regression. And where do we get, what page is this? List and
Oh.
spreadsheets.
Yeah. I thought it was data and something else.
Data and statistics is the, where we graph the data. Okay? So, what is a, hold on a second, I'm just gonna. Okay, you have all the information you need for the rest of this page in between the squared up task and what we just did. So, I need you to do two things tonight, because I want to talk about two quick things after this. I need you to just finish this page of notes, okay? That it is straightforward, it's easy. I also need you to do the last page of squared up. I will let it slide that you have not done it today. If I do not have it tomorrow though, it's going to be 20% off when I usually only do 10% off each day it's late. So, the last page of squared up, I need it done tomorrow. That's where you get the equation and all that stuff. I can send the data back out to the calculator if I need to. Okay? By the way, you can also save these files. The last detail is this. I need to finish grading free response. I think I have one question left for everybody on the free response from yesterday. I also have Josh and somebody else who needs to take the test. Aaliyah.
Me.
Yep. Some of us have done fine. Some of us need to do a retest. And I'm tired of retests where we clearly have not studied efficiently. So, if you're going to do a retest, you're going to stay in here during advisory or come before or after school to do a retest. Some of us, it's the free response with the inference procedures. Some of us, it's the multiple choice. I will give you until next, let's say Monday. That gives me time to grade everybody's or get everyone to take the test, grade it, and give it back to you and study over the weekend. Is that clear? It's the inference procedures with means. So x bar plus or minus t times s divided by the square root of n, or the